Compañeros, welcome to the SQL Data Partners podcast, the podcast dedicated to SQL Server-related topics, which is designed to help you become familiar with what's out there, how you might use those features or ideas, and how you might apply them in your environments. I am Carlos L. Chacon.
And I am Steve Stedman. We are two data professionals trying to help others get a better handle on their database environments, either through this podcast, our training, or our consulting practice. Thanks for joining us on the SQL Trail. Welcome to the show.
SQL Data Partners.
Compañeros, welcome to the SQL Trail and episode 122. It's good to have you back, listening where you might be on your way to some of the in-memory tech way to work. Maybe you're at work already, maybe you're walking the dog, but thanks for bringing us along and allowing us to be a part of your conversation. So today's topic, we're talking about isolation levels, and our guest is Joost de Bruin. I reached out to him. He's a project manager at Microsoft, and he was a previous guest. We were talking about some of the in-memory technology, and I wanted to reach out to him because I was looking at some of the new isolation level options that are available with the in-memory technology. And as we got thinking and kind of talking about it, we thought, you know what, we might as well just go ahead and cover some of the, I'll call them traditional isolation models, because this is super important and something I think most folks just kind of gloss over. And it really is what makes the transactional system what it is. And so ultimately, we're going to be talking with him about not so much specifics on each one, but more a general overview of why they're important, what role they play in the database, and how sometimes we can mess them up, or ways in which some developers try to get around them, and some of the other options that are available to you instead of trying to use some of these functions that you might be using. So before we get into the episode, we do have a couple of shout outs. I want to give a shout out to Tom Garvin. I met up with him in DC, Washington, DC, at the SQL Saturday up there. He's a longtime listener and frequently comments on our episodes, which we appreciate. And so it was nice to finally catch up with him. We didn't have quite as much time to talk as I would have liked, but it was nice to finally get to meet him and chat with him. We have a couple of new listeners that have reached out as well. We've got Elena Costarina and Steve Heinmarsh. Both reached out, that they were new podcast listeners and appreciated what we were putting together. And so we asked for feedback or some ideas on a new feature we'd like to start adding in January, just called Tips and Tricks. Those submissions have been slow to come in, and so we hope that you'll consider, and I'm hoping at least that most of you are waiting because you're thinking, well, there are things that I do, but nobody would find that interesting. And so I think maybe as we get into it and you begin to see what it is, what the type of things that we're doing, that hopefully those submissions will pick up a bit. But we are interested in how you are working with SQL Server, things that you do that you think are kind of cool. And we'll make that little feature in the podcast coming up in January. And of course, if we don't get a ton of submissions, then that will be a short-lived feature of the program. For today's episode, you can reach the show notes at sqldatapartners.com/isolation or at sqldatapartners.com/120partners.com/isolation or at sqldatapartners.com/122. And let's go ahead and get into the conversation with Steve and Joost. Well, Joost, welcome back to the program.
Well, thanks, Carlos. I'm happy to be back.
Yeah, it's great for you. It's always great to talk with the Microsoft folks, and we enjoy you taking some time out to talk with us. It's been almost 100 episodes, and so it's nice to have you back on. So today, we're going to be talking about isolation levels, which might seem like a slightly daunting task, but I think it's one of those very important features. And I guess let's go ahead and maybe set the stage for why isolation levels are important and what do they help us do, right? So I guess how do we want to frame that in this conversation?
Yeah. So isolation levels, so we're talking about transaction isolation levels.
Right.
And At isolation levels, about the degree of isolation you want an individual transaction to have, because in a database system, database systems, SQL Server supports a high degree of concurrency, meaning that you can have lots and lots of different transactions, user operations happening at the same time. So the question is, if you have a transaction that is operating on some data, reading some data, making modifications, to what degree is it isolated from another transaction that is touching the same data, reading the data, and modifying the data at the same time? So that is why isolation levels are important, because what you don't want is, hey, you are making an update on some data. Let's say you have banking software. It's a very classical example. You're doing an account transfer between one account and the other. You want to make sure that the overall balance is between the two is zero, right? If you subtract 10 from one account and add 10 to another account, then at the end of the day, you want to make sure that you have the balance, right? That's only $10 is shifted. You don't want another transaction to come in halfway and look at the data as if there was a higher total amount, right? You want the other transaction to only see the results of your transfer and not
in between, right? State. Right. Yeah. So ultimately, I think if you're writing queries to the database, right, it's how those queries behave with each other, right? That's kind of the idea of our conversation today.
And maybe just to phrase that a little bit different from the developer's perspective, when the developer has an application that's talking to the database, it's how those queries that are coming from that application are going to be talking to the database. It's how those queries that are coming from that application are going to behave. And the different transaction isolation levels may change the behavior of those queries slightly. Is that a fair way of saying it?
Yeah, it is more about it is actually about the interaction between the queries and the write operations. So if everybody is only reading and there's no writes in the database, then isolation levels don't matter. Then there's no difference whatsoever in the behavior between the different isolation levels. It is only in the interaction between the reads and the writes. So if you have a query and some other transaction is doing writes to the database, that your isolation level essentially governs what you can see, what states of the database you are allowed to see.
Right.
Okay.
And what we're trying to solve here is, I think, some of that basic, like, transactional database,
not actually
that would follow in correlation from those updates and reads, right?
Yeah, that's right.
So two terms that seem to always come up when we start talking about isolation levels are the term dirty reads and the term phantom reads. Can you touch on what those exactly mean from the SQL perspective?
Yes. So dirty reads means that is reading data that has not actually been committed to the database, right? So usually when you have a transaction that does writes, you do the write operations, you make the changes in the tables, and then at the end of your transaction, you're doing a commit. And then when you receive an acknowledgement from the server that the transaction has been committed, that means only at that point in time is the data really part of the database. At any point before that, I don't know if it will ever point in time is the data really part of the database. At any point before that, it is actually dirty data, and if anybody reads that data, it will be a dirty read, because before the transaction is committed, it can roll back at any time. And if the server crashes or fails over before the transaction is committed, then it is always rolled back, right? So a dirty read means you are reading data that has not yet been committed to the database, and you don't know if it will ever be committed to the database. So that's a dirty read. So that is kind of, you're getting in very flimsy territory, and usually dirty reads is what you really want to avoid. Phantom reads, that is something very different. So phantom reads, that is data that has been committed to the database, but it has been committed essentially while your transaction
records that are
running. So you are a subtle kind of interaction between transactions.
When you're selecting from a table and you're reading through page by page, as a query does, and something happens that causes pages to shift around in that table. For instance, an index is being reorganized, or somebody is inserted into a page that's full that causes a page split. What can happen when that occurs? You get records that are either duplicated or missing. So phantom records are basically when rows are either being counted twice or they're not there at all. And what that can do is, if you're doing reporting and it has a table that's with this going on, is you can get very skewed numbers on your results. So if you're doing like, here's 10 rows, and then at the bottom, there's a summary that says, here's our total line. If your total line is being calculated and a row moves, some rows could be counted twice and some rows could be missed. If you've got a clustered index or a last updated date or something that can change, and that changes, that causes the placement of that row in the table to move.
Mm-hmm.
And if you're doing something like select count, where from that table, with locking, make sure that you get the right number of rows. But if you use select count with no lock, you can then end up with those phantom records where you have either rows missing or rows duplicated, because using no lock says, I don't care about other people's locking. I'm just going to scan through the pages and grab whatever's there that's not fully committed.
Exactly. So although that work is happening, and it's still going to give you the results regardless of what other people are doing.
Yep. And what that means is you can grab the same row twice, or you can miss a row completely.
Now, I know this can be sometimes, difficult, right, to pinpoint. We had talked about kind of coming from a developer perspective. When you think about testing this or writing your queries against your own database, they happen very, very fast. Even, you try to, quote unquote, load test, and then maybe have some load test, and then maybe have some, some different, windows open, or, connections, and you're trying to replicate some of this stuff. But really, it gets important when that concurrency, when the number of transactions increases at the same time in the database. And that's when you start to see all these rules, start to come in force. And so I know sometimes, I know when I was first starting with this, it seemed a little abstract. but again, that idea of who gets to go first and what's going to happen plays an important role. Ultimately,
yeah, absolutely. But it is important when you're working with a database application, especially if you have sensitive data that you are working on, especially with things like financial data. It is important to really think through data, like how important is it to isolate the reads from concurrent applications, right? So
right.
How important is it that when you do, for example, a range query, when you query all this account data for a single user, how important is it that nobody adds any additional account data to it, right? So that is what you need to think about when you're building a database application.
Yeah, and again, I think this can be a little bit blurry in the sense, particularly when you have all of this. I guess I'll just you use the streaming data, right? Or all for all of these the NoSQL solutions that are coming on the scene, right? Again, you're kind of it's that balancing act of how do you want these interactions to play into, and these are kind of again kind of core fundamental issues. While we want our transactions to play nicely together and that's information, I don't want somebody to see that I've taken 10 out and haven't deposited into the other account while that's going on. But in order for the database to be able to force that, one of the things that I'm going to have to deal with then is blocking, right? Is that to say no, I'm sorry, you can't go until I'm finished. And that's kind of that's the mechanism that the database is going to use to help enforce that traffic, right?
Yeah, that's right. I mean, there are essentially two ways that this can be enforced, right? So first off is you need to make the choice what isolation level is right for your transactions and for your read operations. Because usually you pick an isolation level either for your whole application or for individual transactions, but it is even possible to pick them for individual read operations, individual transactions, but it is even possible to pick them for individual read operations. So that is the first important choice. And then in terms of how these isolation levels are implemented, there are two ways. In general, there are two ways to implement them. One's an optimistic way, the other a pessimistic way. So pessimistic is the default, or has been the default in SQL Server for a long time. And the optimistic way that has been introduced with snapshot isolation for kind of general tables, and then later with memory optimized tables. Also, if you pick the repeatable read or serializable, you also get optimistic. But essentially, the pessimistic model means that you are going to assume that there are going to be conflicts between read operations, so different read operations. They will get into each other's flow. You will always, which means that you need to take a lock on a rows or a range of rows. So basically, if you pick, for example, a repeatable read, in a repeatable read scenario, if you read a row, you will always want to be able to read that same row in the same state at any later point in your transaction. Mm-hmm. Or serializable, meaning that, well, you essentially have a serialization path between different transactions, right? So you don't see any interference between transactions, meaning in practice that if you read a range of rows or you read an entire table, that no rows will have been inserted or into or deleted from that range, right? So in the pessimistic model, you actually take a lock to make sure that nobody can change those rows or this range of rows. Whereas in the optimistic model, what you say is, well, I'm going to anticipate that there are not going to be any conflicts between these different operations. And if there is a conflict, so for example, two concurrent transactions want to update the same row at the same time, you get a failure right away. Or if there is some concurrent transaction that commits but violates your serializable isolation, then your commit fails. So the optimistic model tends to work well if you don't have too many conflicts. And the pessimistic model works well if you have potentially a lot of conflicts. But then, of course, you have these locks, and especially if you use serializable, you can have locks of long ranges of data, and then you can have transactions that start waiting for each other.
Right, and this is where we get into some interesting ideas that have been floating out there. And Steve, I don't know if it's secret sauce before we get started here. And so you mentioned, so SQL Server is using a pessimistic by default, right? So that isolation level read committed.
Yeah.
We know that it wants to protect the reads that are happening, right? So we're going to start putting locks there, and then we start getting blocking. Well, we have this, I don't know if it's secret sauce, right? Or, but there is this idea out there that people can use a function called NoLock, and that somehow is going to get by. It's going to ease their burden, right? And they're not going to have to worry about all these things, right?
Okay, so I think when we start talking about this level, then you are already kind of assuming that you are already using a pretty low level of transaction isolation. So earlier, when we were talking about transaction isolation, we were talking about a minimal level of read. Those are pretty high isolation levels,
right?
When you get actually to the lower end, when you get to read committed, which is the standard isolation level in SQL Server, that's the default. That's the isolation level where you still have some integrity in the database, where you avoid dirty reads. So every row that you read has actually been committed to the database. That is what it means to be recommitted. Right. So you have a minimal level of consistency. But then still, you can still have locking and blocking, because when you're updating a row, right, you need to take a lock on that row so that nobody reads it. But at the same time, I will throw in here as well that we do have read committed snapshot isolation, which is not used by enough customers of ours. So locking, blocking, please use read commit snapshot. Right. Unfortunately, there are some corner cases where the application can observe differences in behavior between read committed snapshot and traditional read committed. But in most cases, you will be fine. So that's what I would point at first.
So I think what we're saying, what we're suggesting here, right, is that if your organization as a rule is using NoLock everywhere by default, right, you probably want to take a look at your isolation levels before you keep slapping that on all of your transactions.
Yeah, so first I would say look at the read committed snapshots option, because what happens is so in SQL Server, so read committed snapshots came to SQL Server in 2005. Unfortunately, because we have legacy, it is still server. Read committed snapshot is still off at the database.
Right.
Now, what does it mean to have read committed snapshot on? Read committed snapshot means that every individual query that you run within a transaction, each individual query operates on a snapshot of the database, and that's the snapshot as of the start of the execution of that query. This means that if there is some rows are being updated by a concurrent transaction, you are actually reading older versions of that row, which means that you can just continue reading. You are not blocked by updates that are happening at the same time.
Now, that row versioning of keeping track of those older versions of the rows, that's done in Temp TB, is that correct?
That's correct, yes.
Okay. So, I mean, one of the things that I've run into is I've come across databases where I think this would be great to run in read committed snapshot isolation level, because people are already doing with NoLock everywhere, and it would be great to make it so that they didn't have to do that.
Yeah.
But then on those same systems, because they're already overloaded a little bit to begin with, and that's why they started using the NoLock, they find out then that their I take a look at it, and the Temp TB is their biggest performance bottleneck. And I guess how big of an impact will turning RCSI on? I assume that's going to put quite a bit more load on Temp TB. And if it's already if Temp TB is already a bottleneck, that would not be a good idea to turn on.
Well, it puts load on Temp TB. And if Temp TB is already a bottleneck, then yes, you could potentially have issues there. However, usually locking and blocking in the user database is often a different performance issue from Temp TB bottlenecks, right? So indeed, if you have lots of Temp TB bottlenecks, and on top of that you have this blocking bottlenecks in the user database, then yes, maybe it will not help you. Maybe Temp TB will become an even bigger performance bottleneck.
But if you have locking and blocking in your user databases and Temp TB is not overloaded, then that's the good scenario to turn on the read committed snapshot isolation level. Is that
exactly?
Okay. Yeah. Okay. Just want to make sure I've got that right.
Right. Well, that's where looking at things like, I think Steve, to your point, the idea is like you're going to trade one problem for another, right? So I'm going to trade my locking and blocking for potential Temp TB issue contentions. As long as I know that that's taken care of, and good care and feeding there, and maybe you've moved that over to your SSDs, or right, is that you want to make sure that you understand the trade-offs and that you're prepared then to deal with them, right?
I do want to put another point to this, and that is there is a difference here in Temp TB utilization between read committed snapshot and general snapshot isolation, because read committed snapshot, you use that snapshot only for the running of a single query, not for your entire transaction. Whereas if you have traditional snapshot isolation, used for the entire transaction, right? So if you have a traditional snapshot isolation, you need to keep the old row versions in your Temp TB for the entire duration of the transaction. If you have long-running transactions in the system, it puts a lot of strain on Temp TB. But if you use read committed snapshot, you only need to keep the old row versions for the duration of your query, which means that there is a lot less pressure on Temp TB compared with full snapshot isolation.
That's a great point.
But I feel like we should, so that
great point.
But I feel like we should, so that the read committed snapshot, however, is kind of an introduction into the in-memory isolation levels, right?
To some extent. So if you look at isolation levels which are supported by memory optimized tables, so memory optimized tables support snapshot isolation, repeatable read, and serializable. Read committed is actually not supported, so the lowest is snapshot isolation. But with memory optimized tables, the row versioning is not done in Temp TB. Instead, it is done in the memory space of the user database, and it is built into the table data structures. So the row versioning is a lot more efficient than for traditional disk-based tables.
So then with the read committed snapshot or the snapshot isolation levels, those could be turned on existing databases without changing the structure of the tables. It's involved in changing over to the Tekaton or the memory optimized style table.
That's right. Yeah.
Yeah.
And and when talking about the way these isolation levels work for memory optimized tables, there you have the optimistic model. So first off, if you have the basic snapshot isolation on memory optimized tables, it works functionally very, very similar to disk-based tables. So you see a snapshot of the data as of the start of the transaction. If there are concurrent writes to the same row, you have these conflicts that are being detected. And throughout your transaction, you always read from the same snapshot of the database, same consistent point in time. Now, where it gets interesting with memory optimized tables is for repeatable read and serializable isolation levels, how they are implemented. Because they're implemented using the optimistic model, which means that you have the same disk row between the time you read it and you commit a transaction. For serializable, you essentially don't see any other transaction committing data in any of the ranges that you read from. And those are the basic guarantees.
Now, you've actually been bringing up, the serializable and the repeatable read quite a bit, but you also mentioned the read committed snapshot, right? Is something that probably more customers should take a look at.
Yeah.
Now, admittedly, let's see, I think I may have had one database I had to put in repeatable read, but I've never worked in a database that's been in serializable. How common is that? And I mean, I feel like I only know it because, it would only be used for like exams and stuff.
Well, yeah, that is true. Because, so it is serializable is the only true transaction isolation. If you want to look at it. So it is serializable is the only true transaction isolation. If you want to look at it from a purist kind of point of view.
Well,
so that
sure,
is where in database research, that is where the research has come from, right? But then when you hit reality, then you have performance, right? And concurrency. And with serializable, with the pessimistic approach where you take the logs, then you have this range of rows that you're reading. And if your query does a full table scan, you take a log on the entire table. And between that time and when you commit a transaction, nobody else can make any change in that table. So that can be very restrictive. So there's a lot of locking and blocking there. And if you don't absolutely need it for this particular read operation, then you don't do it, right? So that is why the lower isolation levels are more popular, and that is why read committed is the default isolation level in SQL Server under serial. Actually, one fact that not everybody realizes is that you can actually pick and choose isolation levels on the query level, and even on the table level within a query. So you can within your query, you can add a hint to the table and say the read on this table needs to be under serializable, for example, but the other tables can be read under a lower isolation level. So you could say, for example, my accounts table, I always want to read that under serializable, but other tables I can read them under lower levels.
So then with that, independent of what your overall database isolation level is, if you have that control on a table by table basis, then you can, as long as you understand what all those mean, you can get the behavior you need between different tables, where you might have one table that NoLock is okay. You might have another table where You need serializable, and it really comes down to how often things are changing, right? Is that correct?
NoLock is okay. I think there are very few scenarios where NoLock is okay.
Okay.
There are some cases where I have heard of some cases where you have an application that, for example, has two connections on the database, and one connection needs to see operations that the other connection did in the database without it actually having commit the transaction. And in that case, NoLock, or rather, I would prefer people use read uncommitted in that case, because then you actually say what your intention is, even though implementation-wise it's the same, but you actually say what is your intention.
Right.
Then that kind of thing might be okay. But otherwise, it is usually used as a workaround around locking and blocking. So semantically, it puts too much like to read dirty data usually, right? So it is more of a performance workaround. And I would say rather read uncommitted. Consider read uncommitted only if read committed snapshots puts too much pressure on your Temp TB, or your application somehow cannot deal with the snapshot semantics of the individual queries.
Okay, thank you. And perhaps I was baiting you a little bit there with the NoLock comment, because I'm a big opponent of NoLock. It causes so many issues from what I see in day-to-day organizations, that there's so much misunderstanding from people out there around you just turn it on as the go faster switch, and that is really not the right behavior of it.
Yeah, read committed snapshot. That is the right go faster switch.
Absolutely. All right. Love it.
It's always good to please your hosts.
Well, no, I guess when I say I love it, I love it because now I can refer back to this section of the podcast and help solve debates that I'll have in the future.
Yeah.
Because
last thing I want to throw in here, besides NoLock, which I guess you should never use, there are a number of locking hints that people would be familiar with that are useful in some cases, where you can say, I want an update lock on this row, or an X lock on this row, and such. I would suggest to before going that route, because these locking hints are typically used to pick and choose on the query or statement level or table level what you actually want. So I would suggest, before going that route, think about whether you can solve that the same problem with isolation levels, because isolation levels you actually declare your intent of what you want to do, rather than you specify what is the mechanism that the server should use. And it's often easier to understand by the user.
Sure. And then from a troubleshooting perspective, right, when you have somebody come in and take a look at it, right, they know kind of from a system setting, right, like you mentioned, here's my intention, rather than having to then find a query and, in this scenario, it's different.
I do want to acknowledge that there are always scenarios, there are always cases where people do have to resort to a locking hint, but I would say do that as a last resort.
Sure. Yeah, I mean, you have that in your bag of of options, right? But don't make that the first one, probably.
Yep. Yeah, exactly.
Okay, so should we go ahead and do SQL family?
Yep.
So how did you first get started with SQL Server?
I got started with SQL Server when I started to work for the SQL Server team. That was in October 2010. I moved to Seattle and started working in Redmond on SQL Server query processing.
And you had not worked with SQL Server before that?
Nope.
Wow. Okay.
Well, so then what made you make that leap? I guess, you're applying for this job and you'd be like, hey, you want to come work in our database? Sure.
Yeah, I was working in academia before. I was working at university doing research, doing some teaching, but I had kind of decided I wanted to move to industry, to product development, to kind of have a more immediate impact on the world, and also work more closely in collaborative teams. and I wanted to work on an interesting.
Maybe we ask you,
SQL Server meets the bill there, and I knew someone else from university who had moved to the SQL team earlier. He told me about an opening. I applied, and that's what happened.
There you go. Now that's interesting. Okay, so now I understand where all the serializable comments came from. Now, obviously, you're working on the team, right? So we won't ask you what you would change about the SQL Server, but maybe we ask you what's the next thing you're working on.
I actually find the first question, I find it interesting. I do want to give an answer to that. What would I change the SQL Server? Right. And that is something I would change if there were no legacy, right? Because I know it's making changes while there are legacy applications very hard. But
sure.
I really wish we could change the defaults on a lot of things. For example, the ANSI session settings like ANSI nulls, ANSI padding, all that stuff. I would.
We want to jump
with the snapshot that we talked about as the default, and a number of other kind of best practices that people have developed over the years. I would like to be able to make those the default in SQL Server. But it's very difficult because we have a long, big legacy, and we cannot break legacy applications, of course, because it would ruin our reputation.
Right.
Sure.
Very interesting. Okay. So was there something you wanted to talk about what you're working on next, or do we want to jump into the...
No, let's jump to the next one.
Okay. So what's the best piece of career advice that you've ever received?
Best is work on something you're interested in, right? That is the best career advice I've received, and is also the career advice I would give. Always do something you find interesting.
Our last question for you today, Jos.
Yeah.
If you could have one superhero power, what would it be, and why do you want it?
What would it be? This is pretty easy for me. I would like to be able to either slow down time or stop time for everybody besides myself, so that I could either do some extra work or more likely take a nap while nobody notices.
True superhero power, right?
Yeah.
To be able to take a nap without anybody noticing.
Exactly. I would like to take advantage of that one myself. All right.
Jos, thanks so much. We do appreciate the conversation, and thanks for giving us some of your time.
Yep.
Yeah, well, thanks for having me on. Always a pleasure.
So I do have a couple of thoughts here as we close up. And one is that you have control over some of the behavior of the system. And I thought it was interesting that Jos did mention that probably more folks, if they're having contention, now locking and blocking, there's a whole litany of things that can go on there. And so there's no magic frequently try to get around. Having said that, one of the options that is available to you is that snapshot isolation. And I thought it was interesting that he thought that more customers could probably take advantage of that. And I don't think that, I guess I agree with that assessment that not too many are. It seems like it's very few and far between where I see it. And it made me think that maybe I need to relook at where I might be able to take advantage of that for some of the customers that I'm working with. One of the ways that we frequently try to get around some of these rules or regulations is with using the NoLock. And we brought it up briefly, but I feel like I want to circle back around to this. And Steve actually had some additional thoughts.
Well, I think NoLock is one of those tools that you should use sparingly. And I think that the cases where people use NoLock are oftentimes being done to cover up a problem. Right. Rather than fixing the problem.
Sure.
And I think the case that you really should be using NoLock is pretty rare and pretty far in between. And that comes back to sort of the whole, if you have a read-only environment where you don't have things happening like indexes being rebuilt, so it's truly read-only, yeah, you're probably okay to get away with NoLock there. But if you're using NoLock in a case where data can be inserted or updated or an index rebuilt or any number of things that could cause a row to move in a table, or even a page split that would cause it to move to a different page, NoLock will cause or can possibly cause phantom records.
Right. And that's the danger there, right?
Yep. And that's the danger. And I've kind of jokingly in the past said, yeah, NoLock's great to use if you don't care about your results.
Yeah.
But I mean, in the cases of a true read-only environment, you're probably okay. But if you have any data that's changing, yeah, you have a risk there of having trouble with NoLock. NoLock is one of my all-time biggest peeves, not in the fact that it's there, but in the way that Take out
I wonder
NoLock.
why.
Sometimes just use it as the simple go faster switch. My query is running slow because of blocking. Okay, I'll throw NoLock on there and now it's fast. No worries. Well, the problem is, yeah, it's fast, but you may not have accurate data there. And you might be totally lucky in your dev environment and you do have completely accurate data because nobody else is using it. And then you put it into production.
Yeah, if you're the only one on the system, it doesn't matter, right?
Yeah.
I mean,
And then you put it into production and find out, my numbers are off. Gee, well, take out
I
NoLock.
wonder why. Now, I know culturally it might be a tough thing to say, hey, guys, maybe we shouldn't be using NoLock. They're going to be looking to you for, well, what else do we do? And this makes me think that we should probably have another episode just dedicated to the snapshot isolation, because I think that there are some things that you need to consider. What are the pros? What are the cons, right? Anytime we make a change, we want to be able to ensure that we recognize and can at least describe why or what's going to happen when we make that change. The benefit, but also the what's going to happen when we make that change. The benefit, but also the negative pieces. And so I think I want to spend some time there and talking a little bit about that and ways in which we might be able to, to get rid of NoLock if that's something that your organization is using quite a bit. So I think that's going to do it for today's episode. Thanks again for tuning in. Always interested in your comments. If you're having questions or issues with isolation levels, we'd love to hear about them. You can leave those again on the website at SQLDataPartners.com/isolation. And as always, you can reach out to us on social media, on Twitter or on LinkedIn. We'd love to hear your comments or thoughts about future episodes, what you should be doing. Of course, we are looking for your tips and tricks, and we'd be happy to collect that feedback as well. You can connect with me. I am on LinkedIn at Carlos L. Chacon. Steve is at Steve Stedman. And compañeros, we'll see you on the SQL Trail.
SQL Data Partners.